Good morning, dear students. Welcome again. First of all, recap our some properties. Such properties are very useful for numerical point of view. So consider, first of all, a table known as summary table. So we can write summary table. Some columns are given below, that is first unit cell, second one number of atoms per unit cell, third one relation between R and A, fourth coordination number, and last we can write volume occupied by particles in percentage. So unit cell, first we write sample number of atom per unit cell, 8 into 1 by 8 is equal to what? 1. R is equal to A by 2, coordination number 6, and volume occupied 5 by 6 into 100 is equal to 52.4. Second, BCC 8 into 1 by 8 plus 1 is equal to what? 2. R is equal to root 3A upon 4. Coordination number 8. Pi root 3 by 8 into 100 is equal to 68%. And the last one, FCC. Here number of contribution 6 into 1 by 2, that is 4. R is equal to root 2A divided by 4. Coordination number 12, pi by 3 root 2 into 100 is equal to 74%. So in case of simple unit cell, you can write number of atom per unit cell is equal to 1. Why? Because 8 corners are present in the cube and contribution by 1 corner in cube is equal to what? 1 by 8. Similarly, in body center, contribution by 1 atom through corner plus through body center, the total contribution is equal to what? Cube. In face center cubic, contribution by 1 atom, contribution through face, total number of atom per unit cell is equal to what? 4. What is R? Radius. A is equal to A is length, radius of a sphere. Volume occupied by particles means what? Packing efficiency. BCC means body center. FCC means face center. So with the help of radius, we can find out what the packing efficiency, or you can say the packing fraction value. Packing efficiency always calculated in terms of what? Percentage. If coordination number is known, then we can find out the geometry of crystalline substance. In next, we have to calculate the radius of different types of voids, that is octahedral voids and tetrahedral voids. So my heading is calculation of radius of octahedral voids. Voids means vacant space, or you can say interstitial sites. Yeah, interstitial space. Okay. Let us consider following pattern of diagram. This is void, four centers because four circle. The cross section of an octahedral is square. Shaded sphere occupied the octahedral void. Suppose this is A, B, C, D. So according to Pythagoras theorem, we can write what? AC is equal to root over AB square plus BC square. AB is equal to what? A's length. And this point is said to be what? Smaller. So you can write what? AB, it means A square plus A square. You can write what? 2A. Again, AC is equal to, this is radius capital R, and the radius of void a small r, so AC is equal to 2r plus 2r. This r is the radius of void, this capital R is the radius of a sphere. You can write root 2a is equal to 2r plus 2 capital R. This is our equation 1. Again, from AB, we can write AB is equal to 2R. AB is equal to what? A is equal to 2R. This is our equation 2. Dividing equation 1 by equation 2. We get what? Root 2a divided by a is equal to 2 small r plus 2 capital R, and here we can write 2 capital R. We get, if we solve, we get small r by capital R value is equal to 0.414. A small r is what? Radius of void. Capital R is equal to what? Radius of a sphere. And this ratio becomes equal to 0.414. So always remember this numerical value कि r void by r sphere means radius of a sphere. The ratio of numerical value become constant, that is equal to 0.414. Let's start calculation of radius of tetrahedral voids. Calculation of the radius of tetrahedral voids. Tetrahedral means if we consider 3 circles, then fourth one become this one. That is, in tetrahedral voids, triangular base, while the fourth sphere lies at the top. Let the radius of void and sphere be small r and capital R respectively. Look this cube. This is your cube. This point A, this point D, suppose. This is B1. This is C. This is A's length. This point is said to be body diagonal. Here we write what? Void. According to Pythagoras theorem, we can write AB square is equal to AC square plus BC square. AC is equal to what? A square plus A square. Therefore, AB is equal to what? Root 2. Actually, AB is equal to 2R. A and B spheres touching each other. So we can write two R is equal to root 2A. R is equal to root 2 by 2A. That is, R is equal to A root 2. This is our equation 1. AD is equal to what? AD square is equal to AB square plus BD square. AB square plus BD square. So AD is equal to what? Root 3. If you solve the value of AD, you will get root 3A. So for AD, you can write what? 2R plus 2R. AD means this is capital R, capital R. For void, 2R is equal to root 3. R plus R, you can write what? Root 3 by 2A. This is our equation second. Dividing equation 2 by 1. We get what? R plus R, capital R plus small r, divided by capital R is equal to root 3a by 2. Here we can write what? 2 root 2. You get a small r by capital R is equal to 0.225. That is r wide by r square. The numerical value is constant 0.225. So this is the numerical value for such type of words. You can take a screenshot. So in your board examination, either determination of radius of tetrahedral word or octahedral word may be asked. Our next heading is radius ratio. This ratio tells us the stability of ionic crystal, coordination number, and the geometry of voids. Consider following table. First of all, we write the ratio of radius of cation to that of anion in an ionic crystal called radius ratio. That is, radius ratio is equal to what? We can write R plus R minus. This is known as radius of cation. This one, radius of anion. This radius ratio is also called limiting radius ratio. Limiting radius ratio tell us what? A stability of ionic crystal. Second one, coordination number, and the last, geometry of voids. So three things we can explain on the basis of radius ratio. Consider following table. Here we can write limiting radius ratio. Second one, coordination number. Third one, structural arrangement. And the last one, examples. If limit lies between 0 to 0.155, our coordination number is equal to 2. Structure means geometry, linear. Example is BeCl2. The geometry of BeCl2 molecule become what? Linear. That is bond angle exactly equal to what? 180 degree. The second one, 0.155 to 0.225. The coordination number 3, geometry, diagonal planar. The example become B2O3. So B2O3 is the correct example. The next one, the range 0.225 to 0.414. The coordination number 4, structural arrangement, that is geometry, tetrahedral. Example become, you can write Zn as silicon dioxide. Next one, 0.414 to 0.732. Coordination number 6, geometry, octahedral. Example become NaCl, or you can write MdO. The last range 0.732 to 1. Coordination number 8, geometry, cubic. You can write cesium chloride or cesium bromide. So if coordination number is known, you can predict the structural arrangement. With the help of limiting radius ratio, we can find out the coordination number for any crystalline substance. Some ionic crystals, their geometry, coordination number, number of formula units, and examples are given below. Types of ionic crystal, the first one is NaCl, sodium chloride. Cubic closed pack structure, Na plus at every octahedral word occupied, Cl minus occupied, CCP, cubic closed pack. Coordination number of both ends become equal to what? 6, 6. That's we can write 6 into 6. Number of formula unit per unit cell, 4 mole is to be considered. 4 sodium ion and 4 Cl minus ion. So the example become lithium chloride and sodium chloride. Our second example, cesium chloride, BCC, body centered cubic like structure, cesium plus body centered, Cl minus at every corner of the cube. The coordination number ratio 8:8, Cs plus 1 and Cl minus 1, 1:1 ratio. The example of cesium chloride and calcium sulfide. Next one, ZNS, zinc blade. Cubic closed pack structure, zinc 2 plus 50% occupied tetrahedral words and S2 minus every element of CCP arrangement, cubic closed pack arrangement. Coordination number ratio 8:4, and the breaking of ion in such a manner. Examples of PaCl2, CaCl2. Next, you can write CaF2 for light type, cubic closed pack structure, calcium 2 plus, F minus, CCP arrangement, tetrahedral void. And here 8:4, and in this case 4:4. And addition 4 mole of calcium 2 plus and 8 mole of F minus. Examples of BaCl2 and CaCl2. Next one, sodium oxide, that is anti-fluoride structure. CCP, close pack, cubic close pack, sodium and tetrahedral void, oxygen 2 minus, cubic close pack, coordination number ratio 4:8, and addition become 8 mole of Na plus and 4 mole of O2 minus. Examples of lithium oxide and lithium sulfide. The last example, our sixth number, ZnS, that is Oxide. Here SCP arrangement become possible, zinc 2 plus and S2 minus. These occupied 50% of tetrahedral bonds. And this become every element at SCP, hexagonal close packing. Coordination number ratio 4:4. And addition 2 plus 6 S2 minus. And examples are similar to previous ZnS. So in all crystal system, at a glance, we can find out their coordination number and geometry of different crystalline substance. Thank you.